Hey everyone, and welcome. Database scaling can feel incredibly intimidating. It's kind of like staring up at a huge mountain, wondering how you'll ever get to the top. But what if I told you it's not about one giant leap? It's a journey with a clear, step-by-step path. And today, we're going to walk that path together and just demystify the whole process. So let's start with a feeling we've all had. Your application starts to lag. Requests are timing out. And worst of all, users start complaining. You found the culprit. The slow database is the bottleneck. But the big question is, now what? Where do you even begin to fix this? Well, you begin with a roadmap. And here's ours. We're going to start with the easiest, highest impact wins you can get right now. Then we'll talk about how to reduce the overall load on your database. From there, we'll get into architecting a more resilient system, tackle what to do at massive scale, and finally, we'll put it all together into one clear, actionable plan. First up, let's talk about the low-hanging fruit. These are the tools you should always reach for first because they deliver the biggest performance gains with the absolute least amount of effort. The first, and honestly the biggest win, is almost always indexing. Think of it like the index at the back of a textbook. Instead of flipping through every single page to find a topic, you just look it up in the back and it tells you exactly where to go. That is precisely what indexing does for your data. It can be the difference between a query taking several seconds versus just a few milliseconds. It's a game changer. But you have to do it right. You want to be strategic. You should index the columns that your database uses to find, join, or sort information. That's your where, join, and order by clauses. But, and this is a big but, don't over-index. Every time you write new data, the database has to update all those indexes. Too many can actually slow things down. So the key is to be targeted. Sometimes the problem isn't the database at all, it's the questions you're asking it. Query optimization is all about rewriting your SQL to make the database work smarter, not harder. You'd be amazed. Simple changes, like being more specific about the columns you need instead of just asking for everything, can have a massive impact without you ever touching your infrastructure. Okay, so you've optimized your code. What's the next easy win? Vertical scaling. This is basically the throw money at the problem solution. You just upgrade your server with a faster CPU, more RAM, or speedier storage. It's simple, it's fast, and it works. But here's the trade-off. On the one hand, vertical scaling is great for immediate gains. You don't have to change any code. But you will eventually hit a physical limit. There's only so much power you can pack into one machine. And more importantly, you're creating a single point of failure. If that one big server goes down, your entire application goes down with it. So think of this as a way to buy yourself time, but know that it's not the final answer. So where do we go from here? Well, once you've made your database as efficient as possible, the next goal is to stop bothering it so much. We can do that by adding some intelligent layers in front of it to take the pressure off. And the most powerful way to do that is with caching. Imagine a workbench. You keep your most used tools right there on the bench, so you don't have to walk over to the giant toolbox every single time you need a hammer. Caching does the exact same thing for your data, storing the hot, frequently accessed stuff in super fast memory. This can reduce your database load by orders of magnitude. Seriously. Another really key technique is connection pooling. See, opening a brand new connection to your database for every single request is actually pretty slow and resource intensive. A connection pool is kind of like a valet service. It keeps a set of connections open and ready to go at all times. So when a request comes in, it just grabs one that's waiting. This dramatically reduces latency and stress on the database. All right, we've handled the quick wins, we've reduced the load. Now it's time to think bigger. Let's get into making some real architectural changes that build a system that's not just fast, but also incredibly robust and resilient. And that brings us to replication, which is an absolute cornerstone of any high availability system. Instead of having just one database, you create multiple copies of it. And there are two huge reasons for this. First, you can handle way more users by spreading the work out across these copies. And second, and this is crucial, if one of those servers fails, your application just keeps on running. So how does it work? Well, you designate one server as the primary. This one handles all the data changes, the writes. All the other servers become replicas, and their only job is to handle requests for data, the reads. This division of labor is what makes it so powerful. It means you can scale your read traffic almost infinitely just by adding more replica servers. This quote right here is one of my absolute favorites, and it perfectly sets up our next couple of techniques. Storage is cheap, latency is not. In modern systems, we are more than willing to trade a little extra storage space for speed because a user's time is the most expensive resource we have. Which leads us to a really counterintuitive idea: denormalization. We're all taught in school to keep our data perfectly clean and avoid duplication at all costs. But for the sake of speed, we sometimes have to intentionally break that rule. By strategically duplicating some data, we can avoid those complex, slow joins where you have to combine multiple tables. The result? Our read queries get dramatically faster. Another really powerful tool is vertical partitioning. So picture a huge table with, 50 columns. For most of your queries, you probably only need to look at 3 or 4 of them. This technique lets you split that one wide table into several narrower ones. That way, your query only has to read the small slice of data it actually needs, which reduces the input-output from the disk and saves a ton of memory. Okay, so what happens when your application becomes a massive global success? When you're dealing with that kind of traffic, you need to pull out the most advanced tools in the toolbox. These are the ones you save for when things get really, really big. The ultimate technique for massive scale is sharding. Instead of trying to make one database bigger and bigger, you split your data horizontally across many smaller independent databases called shards. This allows for nearly limitless scaling, but be warned. Managing data across all those different shards introduces a huge amount of complexity into your application logic. It's powerful, but it's not free. And here's a secret weapon, especially for things like analytics and dashboards: materialized views. Let's say you have a report that runs a really complex, slow query. Why run that heavy calculation every single time someone views the page? A materialized view pre-calculates the result and just stores it as a simple table. So what's the result? Your complex report loads instantly. Wow, we have covered a ton of ground, right? From simple indexes all the way to complex sharding. So the most crucial part is, how do you put it all together? It's not about trying to use everything at once. It's about having a systematic plan. And this is that plan. This is the progressive optimization path. You always start with the easiest wins in step 1, indexing and query optimization. Next, in step 2, you reduce the load with caching and connection pooling. Then, in step 3, you architect for resilience with replication. And only, and I mean only, when you absolutely must, do you take on the complexity of sharding in step 4. The whole goal is to apply the right technique at the right time. So, there you have it. That's the roadmap from a slow database to a truly scalable, resilient system. It isn't magic. It's just a series of deliberate, well-understood steps. Which really leaves just one question for you to think about as you go back to your own projects. What bottleneck are you going to solve first?